Hello, welcome back for chapter 8.1. We are now going to start looking at sets and probability. So our last three chapters will be about that. 8.1 is all about sets. So we can have sets of many different objects. Numbers are mainly what we're going to work with. So it says the set consisting of the numbers 5, 6, and 7 will look like this. We're going to put them in brackets. That tells us that they are elements or members of the set. To show that 5 is an element of the set, we're going to say 5, and then it looks like this E symbol, but it's kind of more rounded. 5 is an element of 5, 6, and 7. And we can see that 8 is not an element of 5, 6, and 7. So we'll draw a line through it. A set with no elements is called an empty set, which is a 0 with a line through. If two sets are equal only if they have exactly the same elements, even though they can have different orders. You can see that here with 1, 2, and 4, 2, 4, and 1, and 4, 1, and 2. And the elements is not important. Sometimes we describe a set by common property of its elements rather than by a list of elements. It is called a set builder notation. For example, X has a property P. So for instance, here in example 1, we say list the elements belonging to each of the given sets. X is a state that borders Florida. So the solution in brackets would be Alabama and Georgia. Next is X is a natural number less than 4. So that would be the set of 1, 2, and 3. C, S is a state whose name begins with the letter E. Well, there are no states that begin with the letter E, so it's an empty set. Next up, we're going to talk about subsets. A set is a subset of a set B, written as A is subset of B. So it's a kind of a sideways U with a line underneath it, provided that every element of A is also an element of B. So for each case, decide whether G is an element, is a subset of H. G is a set of all months that have 30 days. H is a set of all months of the year. Yes. G is a subset of H because every month that has 30 days is a month of the year. B says G is a set of integers and H is a set of odd integers. And that's no, because every integer is not an odd. So G is not a subset of H. Just a side note, empty set is a subset of A, and A is also a subset of itself. A set A is said to be a proper subset of B if every element of A is an element of B, but B contains at least one element that is not a member of A. And so it's the sideways U, but it does not have the line underneath. Decide whether E is a proper subset of F. So E has 1, 3, and 5. F has 1, 3, and 5, but it also has 2 and 4. So yes, E is a proper subset of F. E is a set of diet soda drinks. F is a set of diet soda drinks sweetened with NutraSweet. No. Because not all of E is in F. It's really more like the other way around. Okay. We're going to learn how to draw a tree diagram. A tree diagram helps us kind of set things up a little bit easier. So it says 3 and 5. List all possible subsets for each of the given sets. So 3 and 5 are the items or members in the set. Using a tree diagram, a systematic way of listing all the subsets of a given set. So you don't have to use a tree diagram, but it kind of helps you go through all the possibilities. So we could have a subset of 3 and 5. It's a subset of itself here. And then you could have just the subset of 5. You could have just a subset of 3, and you could have the empty set. So let's do one with the members of cat, dog, and bird. So we could have, is cat in there? Yes or no? And then we could ask if dog is in the subset, that would be a yes or no. And then we could have, is bird in the subset? And that could be a yes or a no. And each of these get a yes and a no. Because we could have no cat, yes a dog, and yes a bird. So here are the subsets. We have cat, dog, and bird. They're all a yes. We have cat, dog, and no bird. So just cat and dog. Then we have cat and just bird. And then we have just cat. Then we have all of the subsets that don't have a cat. So we go down here. So no cat in any of these. So down here we have dog and bird. And then we have just dog. And then we have no on the cat, no on the dog, just the bird. And then we have the empty set. So we ask ourselves, is there a way for us to systematically always know how many subsets there should be, depending on how many members are in the original set? And yes, there are. So we'll see that on the next page. So on the next page, it says, a set of n distinct elements has 2 to the n subsets. So if we go back for a moment to our cat, dog, and bird, we'll see that cat, dog, and bird had 3 in the set, and so it has 2 to the 3, or 8 subsets. So let's look at example 5. It says, find the number of subsets for each of the given sets. So orange, purple, and yellow. So n is 3. We have 3 items in the set. So that means we have 2 to the 3, or 8 subsets possible. What about X is a month of the year? So that means because there's 12 months in a year, we have 2 to the 12, or 4,096 subsets. And then the empty set means that n is 0. So we have 2 to the 0, or 1 subset, and that's just the empty set. Another way to describe sets and their subsets is called a Venn diagram. A Venn diagram is sometimes used to illustrate relationships among sets. So usually we have a rectangle, and this is the universal set, everything that's in the rectangle. That's why I have a U here. And you can see that in this Venn diagram, that A is a subset of B, because A is completely enclosed within B. So we can do operations on subsets. It says, given a set A and a universal set U, the set of all elements of U that do not belong to A is called the complement of set A. The complement of set A is written as A prime. So this entire box is U. So one thing to remember is the number that are in A plus the number that are in A prime always equals your total N, the number of items. So example 6 is giving us a couple sets and wants us to draw a Venn diagram. It says, let U be 1, 2, 3, 4, and 5. A is 1, 2, and 3, and B is 4 and 5. Draw a Venn diagram. So make one that's big enough because you want to have plenty of space to write. And so this is U. And we know that A, I'm going to look and see, does A and B have anything in common? And they don't. So they're not going to even touch each other. So we're going to have A. It has 1, 2, and 3. And then B has 4 and 5. And then it's asking us to list A prime. So everything that's not in A out of the universal. So that would be 4 and 5, which is B. And then everything that's not in B, which just happens to be A. And then everything that is not in the empty set and is not in U. Well, everything that's not in the empty set is U, and everything that's not in U is the empty set. And they don't overlap. So there's no overlap because and always means they have to be in both. So let's just write, let's make a note for ourselves. And means they have to be in both. Okay, given two sets, C and D, the set of all elements belonging to both set C and set D, is called the intersection of the two sets. Written C intersect D, so it's an upside down U. So intersection is the upside down U. So this would be the intersection here. Find the given sets. So we've got A, B, and C, and a universal set U, which includes everything. So we want to know what is contained in A and B. So any items that are in both A and B. It looks like it's 13 and 15. Anything that is in A but not in B. In A but not in B. So it's in A, but it can't be in B. So 9 would be 1. 13 cannot be because it's also in B. 15 cannot be because it's also in B. And 21 is in A, but it's not in B. Number 3 says, find the intersection of A and C. So any items that are in both. A and C. And it looks like it's empty set. Okay. Now, example B says, X is your birth month, it's January, intersect with X is your birth month is March. Well, they can't intersect because you can't be born in 2 different months. So that is an empty set. So for any sets A and B, if A and B are disjoint sets, then their intersection is 0. This is an important statement. Disjoint is also called mutually exclusive. So you'll want to write this down. They don't share any elements. So we've talked about the intersection. Now let's talk about the union. The set of all elements belonging to set A or to set B or to both sets is called the union of the two sets, written A union B. So if we had our universal set there, and then we had A is here, and B, and then they have some intersection, the union means that we include everything in A, everything in B, and everything in both. So, or in both. So you can see there is a section that is in both A and B, and that's going to be important to recognize this piece that's in both here in just a couple sections in the book. So let's look at example 8. Example 8 says, let A be these elements, B has elements, C has elements, and then we have the universal set that's 0 through 12. Find each of these. So we have A union B. A union B is anything that's in both. So we've got 1, 2, 3, 4, and then B has 5, 7, A has 10, and B has 11. Okay, so we have B says, what about A union B, but not in C? So A union B, which is this, and it has to intersect with not in C, so it can't be in C. Okay. So we have 1, because it can't be in C from this list. 2, 3, 4 and 5 are in C, so we can't use them. And then 7, 10, and 11, because they're not in C. Okay, we have example 9. Says an electronic store classifies credit applicants by sex, marital status, and employment status. Let the universal set be the set of all applicants, M be the set of male, S is the single applicants, and E is the set of employed applicants. Describe the following sets in words. M intersect E would be, they have to be in both. So all male who are also, they have to be in both. So they have to be male and they also have to be employed. So B says not but intersecting with S. So not so not male would be female. So they must be female and S. So single. And then C says not M union with not S. So not M would be female or not single. Or both. because that's what the union means. Okay. Our last example. Oh, yeah. Our last example. Example 10. We've got a table. We're going to do a lot of tables in these next couple of chapters. So it says, in the following list of states, let A be the states whose name contains letter E. Let B be the states with a population of more than 4 million. And C be the states with an area greater than 40,000 square miles. So how about we mark them? So I'm going to mark them. A, they contain the letter E. So I'm going to do A here. I'm going to mark them. Kentucky, Maine, Nebraska, and New Jersey. And then B is the states with a population more than 4 million. So that would be Alabama, because this is 4,888,000. So Colorado, Florida, Indiana, Kentucky, and New Jersey. And then, and that's B. And then C, it helps if you have some colored pens too for this chapter 8, 9, and 10. So C is states with an area greater than 40,000 square miles. So that would be, it looks like Alabama, Alaska, Colorado, Florida, not Hawaii, not Indiana, but Kentucky, not Maine, Nebraska, and not New Jersey. Okay. So now it says, describe in words the set of A union, not the intersection of B and C. Okay. So union means anything in A with anything over here. So we know A for sure is going to be Kentucky, Maine, Nebraska, and New Jersey. And then anything that is not in B and C. So not in B and C. So that would be Alaska. I'm going to use initials. It's easier. These are both in B and C, both in B and C. Not in B and C, so that would also be Hawaii. Indiana. And then these other ones are already included because they were in A. Okay. So there's list all elements and it's that A union. Oh, so we already did that. Up here, sorry, I was supposed to do it in words. So in words, it's a state with the letter E or A that does not have a population more than 4 million, nor area greater than 40,000 square miles. Okay. Letter C says, describe in words the set A union B, so not in A union B, but intersects with C. So this would be state that do not contain E, or population over 4 million. And they have to have an area greater than 40,000 square miles. So now it says list all of those elements. Okay, so it might help if we listed A union B. Anything, the A union B prime. So let's list this. So anything that's not an A or B. So that would be Alaska's not an A or B, and Hawaii is not an A or B. And then we have to intersect that with C. So Alaska is in C, Hawaii is not. So Alaska is the only one that satisfies this criteria. These get a little tricky. And that is the end of 8.1. Catch me back for another lesson.